What? I'm sciencing. This is quantum mechanics. Apparently. I mean, it has to be. Someone on Facebook said so. Hi everyone. As you guys know, I'm a moderator in a Facebook group called Math and Physics. On a couple of occasions I've made videos addressing nutters who post there, and it's that time again. The nutter this time is called Alice Violet Entropy, a self-taught physicist who's working on unifying quantum mechanics and general Your red flags went up at self-taught. And you're absolutely right. This is someone who's done her own research. So pad your desks and get your oven mitts. Alice is consistently on about this thing she calls relative stereographic superposition, and the post I want to respond to is the one where she claims to derive the math behind this concept. I will give Alice credit for one thing. She does know how to sound science-y. Let's have a look. Oh, and for those who want to read along, I have copied the post into a PDF, which I'm linking to in the description. The relative stereographic superposition combines two stereographic projections, one for the quasi-probability distribution and another for the gap size, to create a new projection that encodes both pieces of information.
Everybody got that?
Yeah, that does sound like the intro to a quantum mechanics paper. But gap size is not a thing in quantum mechanics, so that term needs to be defined. The mathematical representation involves the stereographic projection operator P, which projects the wave function onto a sphere, allowing for a more intuitive visualization of the superposition. I don't know what projecting a wave function onto a sphere would do. I don't see how it would make it more intuitive, and I don't see why I would want to make it more intuitive at the cost of distorting it. The relative superposition implies that time can exist in multiple states simultaneously, and the quasi-probability distribution is related to the negative curvature of the quasi-probability metageometry of energy.
What you just said is one of the most insanely idiotic things I have ever heard.
Time is not a physical system, but a quantity. It doesn't have states, at least not in that sense of the word. Systems have states. As for energy, it doesn't have geometry, it's a scalar quantity. Quasi-probability metageometry of energy means nothing. Quasi-probability is a statistical thing where you can work with negative probabilities. It sounds really weird, I know, but it's useful in a certain approach to quantum mechanics. Metageometry, that's simply non-Euclidean geometry, like shapes drawn on a curved surface. And energy is a measure of the ability of a physical system to perform physical work. The words all mean something, but when you put them together in that sequence, it's like saying apple winter of automobile. It's just word salad. It does sound science-y, though. The gap size is the negative quasi-probability curvature, and the quasi-probability of the tube falling increases as the gap size increases. Quasi-probability has no curvature. A quasi-probability distribution function is typically represented by a curved surface, but it's the surface that's curved, not the quasi-probability. I don't know what tube you're talking about. I know you're going to explain both gap size and the tube, but you haven't done that yet. So the structure of this article is complete garbage. You have to define or explain your terms the first time you use them. The mathematical derivation for the relative stereographic superposition. Let the fun begin. Let's consider two states, psi of x and psi of x plus delta x, representing the cat's wave function at positions x and x plus delta x respectively. We want to find the relative superposition of these two states. What cat? You haven't mentioned a cat. Why are you talking about a cat? Please don't tell me you're talking about Schrodinger's cat. That has nothing to do with anything you've said so far. And what's the physical significance of adding two different values of the same function that correspond to different x values? The system will never exist in a superposition of those two states because they are states held by the system at different points. Superposition means that the system is in multiple states at the same point. The concept of relative superposition can be represented mathematically using the wave function. Psi of xt equals a psi 1 of xt plus b sine 2 of xt. Exactly, so we're in agreement. Two different points on the same wave are not in superposition. The same point on different waves are in superposition. Could it be that you're just copy-pasting equations without actually understanding them? You know, to give the impression that this is legit science? Adding the values of the red and green waves together at every point gives us a new wave that combines them both. The blue wave is the superposition of the two. First, we define the stereographic projection operator P. P equals 1 plus x squared to the power of minus 1/2. This operator projects the wave function onto a sphere, allowing us to visualize the superposition in a more intuitive way. No, it doesn't. That doesn't even look like a meaningful operator. Applying it to the green wave, we get the blue wave. All the operator does is reduce the amplitude of the wave more and more the farther from the origin you go. Since the amplitude of a wave function relates to the probability of finding the system in a particular state, the operator distorts the wave function in a way that means it no longer represents the system accurately. Operators are not meant to distort the wave function, but to pick out specific pieces of information from it. This operator doesn't do that. It's useless, and it definitely doesn't do what you say it does. Again, I suspect that you saw operators in papers and did something that looks superficially similar to it, without bothering to find out what operators actually do, how they work, and why they look the way they do. Next, we apply the stereographic projection operator to both states. Psi tilde of x equals p psi of x. Psi tilde of x and delta x equals p psi x plus delta x. Now we can define the relative superposition of the two states. Psi of x equals psi tilde of x plus psi tilde of x plus delta x.
Everybody got that?
Yeah, sure. You can define whatever you want. But here you're defining as equal two expressions that are not generally equal.
That's bad.
Can I go now?
Let me show you. Let's use this simple Mach wave function. F of x equals sine x. We apply p to this function and call the new function g, or psi tilde. We check if f of x equals g of x plus g of x plus delta x for x equals 2 and delta x equals 0.1. Nope. 0.91 and 0.78 are not equal. Since your definition is not restricted to any particular type of wave function, it leads to all complex numbers being defined as being equal. Congratulations, you just invented a completely useless mathematical framework. You really have no idea what you're doing, do you? Time-dependent gravitational constant.
And now for something completely different.
G of t equals g naught times f of t. Possible forms of f of t, blah, blah, blah. But as far as we know, f of t equals 1. There's no indication that g is a time-dependent thing. Lots of things have to be modified. Yeah, if you change something, you have to modify other things.
Golf clap? Golf clap.
What's your point? And what the hell does this have to do with the rest of the article? Let's dive deeper into the connections between g of t, quantum gravity corrections, and the imaginary unit. Yes, please! Does this mean we're going to get to the stupid part soon? Quantum gravity corrections. Pi n. Quantum gravity correction factor. Gamma equals square root of 1 minus 2 gm, and so on and so on. This is gravitational time dilation. Times pi n, because we're correcting for quantum gravity, apparently. This suggests that pi n plays a role in modifying the time dilation factor gamma in the presence of quantum gravity effects. Yes. Yes, it does. So please explain where the hell it came from.
My ass.
In physics, an equation that's supposed to describe something physically real has to match physical reality. It has to accurately represent something in physical reality. It's not enough that it's mathematically valid. Imaginary unit and gravity.
And now for something completely different.
I equals square root of minus 1, yes, equals square root of minus g. Little g, gravitational acceleration. This equation implies a deep connection between the imaginary unit and gravity. One possible interpretation is that the imaginary unit is a fundamental aspect of the gravitational force. No, that's actually not a possible interpretation of what you just wrote. If square root of minus g equals the square root of minus 1, then g equals 1. The value of a little g, gravitational acceleration, is a function of a location at the surface of the Earth. It varies slightly, around 9.8 meters per second square. On the moon, it's about 1.6, I think, off the top of my head, and so on. Again, your math does not actually describe physical reality. Twice now, you have pulled something straight out of your ass and said that this suggests or implies something really profound. That's not how this works. You have to show how you arrived at it, and it has to be consistent with empirical observation. At the top of an extremely tall tower with binoculars, those at the base would experience time dilation where...
And now for something completely different.
Time is in relative superposition. No, this is not an example of superposition. It's that different observers make different observations because they're in different frames of reference. That's got nothing to do with superposition. You really don't know what superposition is, do you? I mean, it's introduced in high school physics. This isn't that complicated. I really don't understand what it is you're not understanding. I mean, you did take physics in high school at least, didn't you? Uh-oh. We may be in trouble. She did her own research back then too. I equals epsilon t. Once again, you're pulling something straight out of your ass. I equals epsilon t suggests a relationship between time and the imaginary unit. Yes, the equation suggests that, sure, but you derived it rectally using the pull out of ass method. And you can't just make stuff up, claim that it means something profound, and think that anyone should take you seriously. And we're back to I equals that stuff. I equals gravity. Suggests a connection between the imaginary unit and gravity. Where did that come from?
My butt!
I is a number. It's an imaginary number, but imaginary numbers are just numbers. It's like the number 4, except it's along the imaginary axis instead of the real axis. Gravity, as far as we know, is one of the fundamental forces of nature. A number and a force of nature, you can't equate those. Equating those makes as much sense as saying that 4 equals electromagnetism. It's a category error. If you cross your eyes hard enough,
And now for something completely different.
you'll be able to measure the distance, time plus probability. What? You can't add a time and a probability together. And even if you could, you wouldn't get a distance. To the edge of the table that the probability of the item will fall. I have a piece of white notebook paper. Okay, we're describing an experiment. 3 inches from the edge, about 2 from the tip. Let's do the experiment. It's time to get to the stupid part. This is what I see. This has to be the gap. The idea seems to be that if I push the tube to my right, this tube has a chance to fall down the gap. And if I push it to the left, this tube can fall down the gap. When I don't cross my eyes, the probability of the former is 1 and the latter is 0, because there is no gap to the left of the tube that I see. But the result will be different when I do cross them, apparently.
A few minutes later.
Well, I can conclude that whether the tube falls or not has nothing to do with how much I cross my eyes. The experiment shows that the probability of the tube falling, regardless of which way I push it, is the same whether I cross my eyes or not. If I push it right, it always falls. If I push it left, it never falls. What a surprise. It's almost as if the laws of physics work as expected. Now, in fairness, I suppose if I'm going to be really generous, it could be that if I did more runs of the experiment, I would have noticed a difference. This is supposed to be a quantum effect. It's supposed to be negligible at macroscopic scales. So you know what I did? I did another experiment. Instead of looking at a large classical object like a tube of toothpaste, I set up a double slit experiment. Now, I could only set up a classical one with a stream of photons rather than individual ones, but I figured that a stream of photons still exhibits clear wave-like behavior, so it should be much more sensitive to this effect. I looked at the double slit with my eyes normally and crossed so that I see one beam going through 2 slits and 2 beams going through 4 slits, alternating between the 2 states. If the wave function is affected by my crossing my eyes, this should affect the interference pattern on the screen, which I recorded on camera the whole time, thus eliminating my cross-eyed subjective perception from the equation. Much to absolutely no one's surprise, not a damn thing happened to the interference pattern. Now, one objection that can still be raised is that, although this violates established physics, crossing my eyes puts me in a different frame of reference than the camera. That is, the modified interference pattern I can see with my eyes crossed is not an illusion, but a relativistic effect that is physically real for me, but not the camera. If this is the case, and it shouldn't be since the camera and I are co-moving observers at the same gravitational potential, I should still be able to experience the effects of this relative superposition with more than just my eyes. So I decided that I should design another experiment to test for self-interference. I'll look at my finger, cross my eyes so that I see 2 of them along with 2 hands, and then I'll scratch the back of one hand with the finger on the other. If I can feel it, we have demonstrated that the 2 hands are not just a visual phenomenon, but that they can physically interact, just like a single particle going through both slits in a double slit experiment. This would prove that the 2 hands exist in superposition, and that it's not just a visual illusion. Well, the results are in. I can't feel shit. What a surprise. Here's some advice, Alice. If you don't already own one, buy yourself a quantum mechanics textbook used in an introductory quantum mechanics course at an accredited university. Now, instead of just memorizing the big sciencey sounding words and fancy looking equations, Learn what they actually mean. Then, and I can't stress this enough, do the exercises in the book where you actually get to use the math. That's how you learn. Memorizing and understanding are two completely different things. Look, crossing my eyes will affect my visual perception of what I'm looking at. It won't affect the physical state of it. Not according to classical physics, not according to relativity, and no, not even according to quantum mechanics. 3 fields you clearly don't even understand the basics of. See ya.